Hello. I came to present you with the first part of our case study. Our case study topic is mathematical model of the active shock absorber in a quarter passenger car suspension system. Me, Chandler Curley, and Michael Habib are the two lab partners that have been working on this. This is for DMC Lab Section 102. We wanted to talk about there are three different types of suspension systems. The first suspension system is passive suspension. The second is semi-active suspension. And the third is active suspension. In a passive suspension system, there are many applications to it, but there are also downfalls to it. We want to talk more about passive and active between the two and the differences. And with passive, it's what you typically see underneath cars nowadays. Because until as of late, cars haven't been really computerized enough, or we had the technology to have a more efficient active suspension system. And in our DMC class all semester, we have talked about passive suspension systems underneath the quarter car, and we've done some mathematical modeling with it in class, which is one reason why we chose this topic. In passive suspension, it is a set spring and dampener rate. This is set by a design engineer who has gone through several different testing to see whether they want more comfortability or handleability for that particular car that's being designed. And once it is set, that's the only thing you can do with it. In this suspension system, you have to the spring stores the energy and the damper displaces the energy or dissipates. And you do have to compromise with your road handling and the passenger's comfort is one of the major downfalls to a passive suspension system. And it is also an open loop system. Another disadvantage of passive suspension is if heavily damped, it will have good handling. However, it will not ride well. But if you only lightly dampen it, it will ride well, but it won't be very stable. It won't handle well whatsoever. It won't corner well or merge well. In an active suspension system, it solves the problem between comfortability and controllability. As long as you have a computer that can read the road and is able to send information to the force actuator, then you are able to control the amount of force that's put into the dampener and the spring in and of themselves for each go around. Therefore, you're able to, like I said, control the comfort and the handleability of the vehicle. It's not a fixed system, which is another good thing about it. And the better the computer is, of course, the more efficient it will become, and the better the ride quality will be. The force actuator is what actually basically dissipates the energy because of it sending it to the dampener and how much it's supposed to control. And it's a closed loop control system, whereas passive was an open loop. The only disadvantage to an active suspension, is the fact that you have to have an actuator and it's computerized. And with the actuator, that's just one more thing that could potentially have to be replaced later on down the road. And a comparison between the two is they both have spring mass dampener systems, and they both control the comfort and handling of a vehicle, even though they do it in different ways. Thank you.